Okay, so we're going to start with momentum this week. The formula is pretty simple. Momentum is mass times velocity. Okay, so I kind of think of it, it's very similar to force. Force is momentum times acceleration. But momentum is kind of the amount of oomph something has, and so if something's floating in space, you need a certain amount of force to stop it from floating. Let's go over an example. For existence, I know that a bullet, let's say that is traveling about 2,500 feet per second. Okay, that's going to be our velocity, but we also know that the actual weight, or the mass I should say, is 7.45 grams. Alright, so if I convert feet per second into meters per second, that's about 762 meters per second. And I times that by the weight, which in kilograms would be 0.00745 kg. Alright, when I calculate that out, I get 5.6. That's my momentum. The units you use is actually kilograms per meter per second. Okay. But now, that's kind of telling us the amount of oomph this thing has. I like to compare it to a pitch in Major League Baseball. It's about 90 miles per hour. Okay, and a baseball, I looked this up. A baseball is actually 145 grams. The mass is 145 grams. So 90 miles per hour, if you go backwards, is about 40 meters per second. And when you times that by the weight, that's 0.145 kilograms. When you multiply that out, you actually get 5.8 kilograms per meter per second. Okay, so if you look here, actually an average bullet has about the same momentum as a baseball pitch. Okay, which I thought was pretty surprising. Now you may be thinking like, yes, a pitch in baseball is dangerous, but a bullet's way more dangerous. The reason you're thinking that is because of kinetic energy. Kinetic energy, remember, Ke is actually 1/2 mv squared. And you'll notice here, yes, we are halving it, but we're squaring the speed. So the bullet, because it's going so much faster, it's going like 15 times faster. That means it's actually going to be way more kinetic energy because you would square the velocity. So let's actually find the kinetic energy of both of these so we can kind of compare. Because kinetic energy is what makes the bullet so much more vicious. So let's say the kinetic energy of the bullet, that would be 1/2 mass, which is 0.00745, really small. But the velocity there is going to be 762, and we're going to square that. Now I'm putting this in my calculator here. 1/2 times 0.00745 times 762 squared. About 2,163 joules. So, I mean, with sig figs, that's probably 2,200 joules, 2,100 joules. Okay, so that's a lot of joules. Let's do the kinetic energy of the baseball. So I'll do double BB there. That would be 1/2. The weight is going to be larger, but it's much smaller, so much slower. So we're going to have 40 squared. Crunch in the number now, and I get 116 joules. So around 100 joules. It's actually 20 times more kinetic energy just because of that speed. So another example that is really nice to go over is, and a way to look at it is, and I've seen this online, they said compare a meatball to a truck. Okay, so let's say the meatball has 1 kilogram and the truck has 1,000 kilograms. Really light truck. Okay, but the meatball is going 1,000 meters per second, and this truck is going 1 meter per second, so it's going really slow. If you look at the momentums here, this is going to be 1 times 1,000, which is just 1,000 kilogram meters per second. And this is the same, because you're going to do 1,000 kilograms times 1 meter per second, which is still 1,000 kilograms meters per second. Okay, so they have the exact same momentum, because the meatball is going 1,000 meters per second. When you compare their kinetic energy, and just thinking about it, which is more dangerous, a truck going a meter per second, or a meatball going 1,000 meters per second? And so, the 1,000 meters per second is going to make the kinetic energy extremely large. So there's my mass, and then I need to do my velocity squared, which would be 1,000 squared. When I work this out, I'm going to have 500,000 joules. That's a lot of energy. Now the kinetic energy of the truck, though, is going to be 1/2 times 1,000 times 1 squared. And so the kinetic energy here is only 500 joules. And so if you think about momentum, I kind of see it as how much it would take for the truck to stop. They have the same momentum, but the energy behind it, the meatball would be able to break through something with that speed. And so there's the biggest difference.